Hello everyone, welcome to today's webinar. Before we get started, I have a few housekeeping items. On the right side of your screen, you will see a Q&A window. Please use this to submit your questions for our presenter and moderator at any time, and we'll address them while they come in. At the conclusion of today's presentation, there will be several poll questions while we're doing the live Q&A. Please use this opportunity to give us some feedback when you see these poll questions appear on your screen. We are recording today's session, and we'll send you a follow-up email in the next few days with the links to the deck and the recording. Again, welcome to today's webinar, How to Integrate AWS Directory Service with Office 365. Our presenter today is Ron Cully. Ron, welcome. The floor is now yours.
Thank you very much. And thank you all for joining the webinar today. Let me talk briefly about what we're going to cover today. First, we're going to cover what AWS Directory Service for Microsoft Active Directory is. For short, I'll be calling that AWS Microsoft AD. Next, we'll be covering some models for authenticating Office 365 with Active Directory credentials. Then I'll be talking a little bit about the deployment models that are possible when using Office 365 with AWS Microsoft AD. And then finally, we'll go through step-by-step setup instructions on how to use Azure AD Connect and Active Directory Federation Service with AWS Microsoft AD. All right, so AWS Microsoft AD is a managed actual Microsoft Active Directory. It's running on Windows 2012 R2 domain controllers. These are dedicated to you. They're not multi-tenant, they're single-tenant solutions. It takes about 3 clicks to set up the directory. You specify the domain name, the NetBIOS name, the administrator password, and that's about all you need to do. You can also script this through the API. When we start the directory, AWS creates 2 domain controllers, or DCs, that are in separate availability zones. You can scale this out to meet your performance requirements by adding additional domain controllers as needed. The service includes dynamic DNS so that when you join Windows EC2 instances or Linux instances or even on-premises computers to your directory, that those are resolvable through DNS. And the directory has been compliance audited for HIPAA and for PCI. Now, there's a shared responsibility for managing the directory. Amazon, as the domain administrator, operates the directory. It handles the multiple availability zone deployment. It does the patching, the monitoring, the DC recovery, snapshots, and restores. We create an organizational unit that you, as the customer, administer. And this is where you would configure password policies, configure trusts if you're using a resource force deployment, configure certificate authorities if you're using secured LDAP. You would configure federation here. You would do administration of your users groups, your group policy objects, and other AD content. And that is all done through the administration tools that you're familiar with using with Active Directory, such as Active Directory users and computers. And then you would also add domain controllers as needed for your performance. The directory comes in 2 editions. There's a standard edition and an enterprise edition. The enterprise edition has a storage capacity of about 17 gigabytes, and that's for your directory information tables, so that this is where you store all of your objects. And the standard edition has 1 gigabyte of storage. We've performance optimized these so that the enterprise edition is for companies with 100,000 or more employees, and the standard edition is for companies, small and mid-sized companies, up to about 5,000 employees. The enterprise edition has the same features as standard edition, plus some enterprise features. At the current time, the feature set is identical, but over time, we will be adding more features to the enterprise edition that are relevant to the largest enterprises. The directories are priced on a per domain controller basis with a 2 domain controller minimum, and the directories are available under a 30-day limited free trial period. Let's talk about the different models available for authenticating Office 365 users against Active Directory. The first model is to synchronize usernames and passwords. Here, Azure AD Connect synchronizes users and passwords to Azure AD, and then Office 365 users log into Azure AD using the same username and password that they have in their on-premises Active Directory. To do this model, it requires domain administrative privileges in Active Directory to set up Azure AD Connect. This is not possible with AWS Microsoft AD because AWS is the domain administrator, and we delegate an organizational unit to you that you have administrative control over. The second model is to synchronize usernames and use pass-through authentication to Active Directory. This is a model that's available through Azure AD Connect, where Azure AD Connect synchronizes usernames to Azure AD, then Office 365 users log in to AD with their AD credentials. In the past, this was unsupportable by AWS. Well, Microsoft had this feature in a preview status, but recently Microsoft has moved this to general availability, so this is now an available option for you. The third model is to synchronize usernames with Azure AD Connect and then use Active Directory Federation Service to do the authentication. Here, Azure AD Connect synchronizes the usernames to Azure AD, and then Office 365 users log in to AD using the federated authentication through ADFS. And this works with AWS Microsoft AD, and it also supports other SAML-based cloud applications if you wanted to do SAML-based authentication for things other than Office 365. Well, you can use Model 2. We're going to talk about Model 3 today because it has a little bit more broad applicability to additional cases beyond Office 365. There are a couple of deployment models that you can look at with AWS Microsoft AD. The first is a resource directory model. In this case, you have an on-premises Active Directory, and you may have an Azure AD account and Office 365 account in the cloud. If you use a direct connect or VPN connection, you can link your on-premises directory to AWS and create AWS Microsoft AD in the cloud with a trust back to your on-premises network. With the trust in place, you can add EC2 instances to the directory in the cloud, and you can use group policy to manage those instances. And you can also authenticate and authorize applications and people that are using those instances. For example, you can run a variety of different AD-aware workloads, such as Remote Desktop Licensing Manager, .NET Applications, SharePoint, SQL Server, or Enterprise Certificate Authority on EC2 instances. And you can use the directory to manage those applications, access to the applications, and authenticate users and authorize. And this is being done using identities that are stored in your on-premises directory through the trust. You can also use this to work with AWS applications and services such as the AWS Management Console, Amazon Workspaces, RDS for SQL Server, QuickSight, and others. In this model, you would install Azure AD Connect or ADFS on your on-premises network and connect those to Azure AD and Office 365, and then you would be able to have your users accessing AWS resources in the cloud, as well as accessing Office 365. The second deployment model with AWS Microsoft AD is to use it as a primary directory. Here, you do not have an on-premises Active Directory. Instead, you install AWS Microsoft AD directory in the cloud, and you administer your users in the cloud. In this case, you would add ADFS and Azure AD Connect on EC2 instances running in the cloud and connect those to Azure AD and Office 365. This allows you to synchronize the users and use SAML authentication. This is the model that we'll be covering throughout the rest of the presentation. The first step is to set up the environment in which you'll run Azure AD Connect and ADFS. To do this, you'll need to install Microsoft AD in your VPC. The next step is to join an EC2 Windows Server instance to AWS Microsoft AD in that domain, and you'll use this as an administrative instance. Next, you'll install the AD administration tools on that instance. You create a separate server for running ADFS in the cloud. Now, this needs to be a Windows Server 2016 implementation of ADFS. Next, you'll create another instance that would be for Azure AD Connect. Now, it turns out that you could install all of these services on a single EC2 instance, but for the purposes of this webinar, I'm going to be treating them as separate server instances. You might want to have them on separate instances in order to scale them out depending upon the scale of your deployments. Next, you create an ADFS service account that you will use for ADFS in your Microsoft AD. And then you need to set up your Office 365 account and set up Azure AD domain. Now, to install the EC2 instances, I'll walk through this briefly. This information in this next sequence is available in our labs up in the Directory Service documentation. So first, you create a virtual private cloud. You will create 2 subnets in different availability zones. If you have an on-premises network that you want to connect to it, you can set up a VPN or an Amazon Direct Connect link to your VPC. That's optional depending on your situation. Once you've done that, you create the directory, and Amazon will create the 2 domain controllers with dynamic DNS, and these will have elastic network interfaces into your subnets. Each of these has a security group available or that is used by them to secure access into the domain controllers. These security groups should not be reused by you for other EC2 instances. These are dedicated for use by the directories. Next, what you'll do is you will set up DHCP option sets to point to the DNS servers that are running on AWS Microsoft AD. Next, you'll create a security group that you'll use for your EC2 instances. Next, you'll create a role with the policy of Amazon EC2 role for SSM in your network. Next, you'll download a key pair file or a PEM file that you'll use to create your EC2 instances. Next, you create your EC2 Windows instance in the cloud, and that will use the DHCP option sets. And it can use what's called seamless domain join. That's what the IAM role is for, is to allow you to seamlessly domain join the instance to AWS Microsoft AD. Once you're done, you'll be able to administer the system after you've installed the administration tools on that management instance. And you'll be able to go into Active Directory users and computers, and you'll see that there's an organizational unit. In this case, it's example, and that's where you will manage your users and computers, and you also have the ability to manage service accounts. The first step to enabling Office 365 is that we need to create a container that ADFS requires, and that needs to be created in your AWS Microsoft AD. To do that, you will first go in and use an RDP session to your AD admin tools system, and you will create a global unique identifier that will be used for the container. Next, you will create 2 containers. The first container is a container named ADFS. The second container is created inside of the ADFS container, and the name of that container is the GUID that you created in the last screen. After you're done, you can use Active Directory users and computers and explore the directory and verify that you successfully created those containers. After you've created the containers, the next step is to install ADFS on an EC2 Windows server. And again, this has to be a Windows 2016 server. It requires ADFS 2016. To do this, you first install the feature by doing an RDP session into your ADFS server and install that feature. After the feature is installed, you need to install an SSL certificate that ADFS uses. There are many different ways of doing that. One way is that you could use a Microsoft Enterprise Certificate Authority that is joined to your AWS Microsoft AD directory. And there's a link here, and I'll include this link at the end of the slide presentation, where you can learn how to do that. Another option is that if you have other certificate infrastructure in place, you can upload or import the certificate that you need using the Microsoft Management Console. If you're going to import the certificate, you install the Certificate MMC snap-in and for your local computer, and then you use the Certificate Import Wizard to import your certificate file into the system. Once you have the certificate on the system, whether you use import or whether you use the Microsoft CA with auto-enrollment, you need to obtain the thumbprint from that certificate for use in the next step. Next, what you're going to do is begin the installation process, and we need to create some variables that contain the parameters that are necessary. The first thing is to create the admin config variable, and what you're going to do is enter in the GUID of your ADFS container that you created earlier. Next, what you'll do is you're going to set a service credential variable, and you'll do that by obtaining the ADFS service account that we created at the very beginning of this when we were setting things up, and you'll use this to obtain the credentials. Next, you'll need to obtain the credentials for your organizational unit, and you'll do that and set that in the local admin credential variable. With that complete, you can now install ADFS, your ADFS farm, and you'll use the certificate thumbprint that you recorded earlier, and you'll specify the name of your federation service, which in this case is sts.awsexample.com. Now you need to publish a DNS record, a record, so that the cloud can discover your ADFS server. So you'll go into the Amazon Management Console and go into the EC2 dashboard and find your server. You'll log into your DNS hosting provider that publishes your DNS records on the internet. You'll create a host name that is the name of your ADFS server, which is sts.awsexample.com. You'll set the record type to an A record, and you'll specify the IP address that comes from the EC2 dashboard for your instance, and making sure you're using your public IP address. Once that's complete, you now need to enable ADFS to run the sign-in page. And so you'll, from the PowerShell, use the set ADFS properties command and enable the initiated sign-on page. We've now completed setting up the ADFS service on the server, so now we need to connect it to Office 365 so that it will authenticate using ADFS. So to do this, from the ADFS instance, you will log into it using RDP as the admin account. This is the OU admin account that we create for you in the directory. And you'll connect to Azure AD using PowerShell. And there's a document from Microsoft on how to do that. And here's the link is here on the screen. You'll follow the prompts through their site and get into the PowerShell. And once you're in PowerShell against ADFS, you will first set the context to your ADFS server using your internal fully qualified domain name, which in this case is adfsserver.awsexample.com. If you remember back in the earlier slides, that was the name that we gave to the EC2 instance for the ADFS server. This is not the public name, but the internal name of the computer. Next, you're going to convert Azure AD to use ADFS server for federated authentication. And you'll do that by running the convert MSOL domain to federated and specify your main domain as awsexample.com. That's the domain name for the AWS Microsoft AD directory. Now that that's complete, we can install Azure AD Connect on EC2 Windows and configure it to synchronize usernames to Azure AD. So what you do is you will RDP into your Azure AD Connect instance. You'll download Azure AD Connect MSI from Microsoft and install with custom settings. In this case, you want to make sure in the user sign-on screen that you do not configure. Now, this is where you would set up pass-through authentication if that's the model you wanted to use. But in this case, we're going to say do not configure. Then on the following pages, on the Connect Directories page, you'll choose Active Directory as the directory type and choose Microsoft AD Forest as your forest. And then you'll enter your AWS Microsoft AD admin credentials again to authenticate into the directory. With that in place, then you'll get the domain OU filtering screen. And from there, you specify, you click the box to say, I want to synchronize my users. This will enable you to synchronize your users into Azure AD, and it will just be the user accounts, not the passwords. So now we've completed everything that you need to do to connect your AWS Microsoft AD to Azure AD in the cloud and configure Office 365 to use the ADFS server. So the next step is to simply configure your user accounts and log into Office 365. For this step, you first need to grant access licenses for Office 365 to your end users. So you'll go to portal.office.microsoft.com, go to the admin portal there, logging in as your global administrator account, and you will then grant the licenses to your users. Once the users have those licenses, then the users will be able to log into Office 365 using their portal access and specify their Active Directory credentials that are stored in AWS Microsoft AD, and they'll have access to Office 365. Here are a set of additional references that you may want to refer to when you do your actual setup. We have how to enable your users to access Office 365. There's a blog post that we've posted on that, and that covers all the steps that I've done in this webinar today. We also have how to set up AWS Microsoft AD and join EC2 instances for administration. This appears in the Directory Service documentation in the tutorials area. We also have a link on how to enable LDAP-S with your Microsoft AD directory. And the purpose of this one isn't necessarily, in this case, for LDAP-S, but it tells you how to set up the Microsoft Enterprise Certificate Authority so that you could do a automatic certificate registration on your ADFS server rather than having to do an import from a different certificate authority. And then we have the main web page for AWS Directory Service to learn more about the product, as well as our main documentation link here for AWS Directory Service documentation. Thank you very much for attending today, and we'll turn it over, I guess, for questions now.